one more thing I didn't get to with Mercury that I think is really an interesting counterpart to this business that we were toying with about, whether the planets change size over time. One thing that's really strange about Mercury is it appears to have shrunk, which is very interesting. The timelines of the formation of the planets is hardly established in so much as we can only say the last time that their surfaces were melted, which appears to be 4.5 billion years ago for most of the ones that we've been to. And, maybe as planets evolve, they go through different phases of growing and shrinking as they cool. The Moon and Mercury are very cold, right? We hypothesize that Mercury has a liquid core because it has this weak magnetism, but we're not sure about that. It has no tectonic activity, no magma, nothing like that. So, there's also this thing to consider about Mercury, which is that it's very dense, and if it does have a really strong, solid core, if it has a really dense solid core, we know that iron and nickel are very capable of retaining magnetism once they've been magnetized. So it's possible that it did have more fluidity in the past, and what we're seeing is just a remnant of that, which is retained by the solid core. But these are some of the little folds that we see. So I mentioned that it looks like it's shrinking. And that is because it has these little escarpments. You can kind of see them here, which look like these folds over which there's a few craters laid. And it's kind of, as you can imagine, that something would wrinkle as it was shrinking up, right? This is the thought. But again, people are trying to explain what they're seeing at all times. The more that we can see about these objects, the more our stories change about them. Okay, and before I get into Venus, which is our subject today, I want to mention this podcast that we just released, which I think some of you might really enjoy because I mentioned this briefly. We were talking about what exactly light is at one point, and really that paradigm is shifting really strongly in physics right now. The Nobel Prize in Physics this year was given to a gentleman named Clauser, actually 3 people. I'm not going to remember all their names, but the Clauser experiment is extremely important because what Clauser was able to demonstrate was this concept of entanglement, which is this idea that atoms influence each other at a distance rather instantaneously, which seems like magic, but Carver Mead at Caltech has championed this idea that light is not just these little bullets that are shot out of one atom. They're actually a conversation that's happening between 2 different atoms. And it was a real pleasure to hang out with Carver and talk about this interpretation of Maxwell's equations, which are our basic, like, floor plan, basically our, they're like our floor plan for how electromagnetism and light work. And so this is a really awesome conversation. If you're interested, he does a better job than me explaining exactly how we can look at the phenomenon of light as a transaction, and we can actually explain this spooky action at a distance business without any magic, which is pretty cool. So check that out if you want. This is a really good one. And with that, let's look into Venus, because Venus is our sister planet for all intents and purposes. This is Venus. This is about as good as Venus can look from the Earth through a telescope. And Venus has been, it's one of the brightest objects in the sky, and so it's played a central role in the historic astronomy of almost all peoples. And as a result of that, because we know that astronomy was deeply tied into the mythology of each culture, the gods and goddesses associated with Venus have played a critical role. And I want to spend a bit of time today playing with those stories and seeing how they overlap, because what's absolutely astonishing is that cultures on different sides of the ocean who had no knowledge of each other came up with very similar stories about Venus. And, you know, this seems in some sense impossible, but at the same time, all of these people were essentially looking at the world the same way, that they lived on this disk. There was this big dome over top of them, on which these unimaginable entities were playing out their motions. These planets, right, they didn't conform to the normal motion of all the stars, so there's something special about them, right? They make strange patterns. They go backwards, sometimes they go forwards. They're very strange. They appear to have some autonomy. And so I think they were natural candidates for being personified. And, you know, it's very easy to think that personifying celestial objects is a sort of primitive way of looking at them. But I think that it wasn't so primitive, because these people were organizing some of the first civilizations that we have record of. And organizing a society is no simple task, actually. In the absence of organization, you have chaos, and you have the baddest people are basically able to do whatever they want. And so how do you bring some order to all of that? Well, you have to centralize stories of how things should be, ideally, right? Because you need something to aspire to, essentially. And so I think that that's really what these gods are. They each represent some personification, some personality, right? That's very archetypical. I mean, think about all of your friends, right, that you've had over the course of your lifetime. You can probably say you have, bring to mind right now, maybe 100 different people you've known pretty well over the course of your life so far. You can probably bin them into certain categories. You know, you have your sort of mischievous friend who's always playing tricks, or you have your very quiet, sensitive friend who's very thoughtful and philosophical, and these personalities appear over and over again all throughout time. And so, and the dramas that we experience, right, our loves and losses, they also play out, and they played out for thousands of years for people. And they played out even before we had stories to explain them, except it was extremely chaotic, because someone dies and you don't have anything to say about it. You just have a friend one day, and next day you have a body there where your friend was. And that's almost impossible to reckon with, actually. I'm sure a lot of you have experienced loss already. It's almost enough to break you, right? And if you don't have a framework to hang that on, it probably will break you. And I'm not saying that you need to have a framework like your friend is in the afterlife or something, but you need to make it meaningful somehow. You need to fit it into your society as a whole, such that you feel that that person's contribution remains within the world and it's significant. And I think that's what these ancient people were trying to do. And Venus plays a really wonderful story across these cultures. So we're going to get into that. So let's take a look at all the historic astronomy. Let's talk about how we've explored Venus, because exploring Venus has been a nightmare. It's very, very hot. You can basically land a spaceship on it for about 30 minutes before, all hell breaks loose and the pressure smashes your ship and the heat cooks all of your instruments. And so it's been a very interesting planet to study, because unlike the moon, we can't just put something there and transmit back for decades afterwards. It can only go for just a moment. We also can't really fly around Venus and check it out, because the atmosphere is so thick and hazy that we can't really see the surface. And so it took a little while to develop the tools to be able to even get information back about the landscape. And that's kind of a remarkable story in and of itself, and brings in some of our conversations about how to utilize light to get information that we want. And then finally, at the end, hopefully we will get around to talking about the actual geology and the origins of Venus, of which I would say almost less is known than any other planet. It's a very difficult one to talk about. It's often the case that we treat Mars as our sister planet. You might come to think of it that way because so much attention is focused on Mars. And obviously that's because you could hypothetically go to Mars and walk around on it without cooking yourself to death. So it's a much more attractive planet. But in reality, Mars is actually something like 10% the mass of the Earth, which you probably didn't realize. And it really doesn't geologically share too many features at all with the Earth. It doesn't seem to have any active tectonics, or we can't really say too much about its core because of that. And so Venus is really, really a planet that we can look to and try to imagine how its evolution might parallel ours. And there's a number of stories, there's a number of narratives that are floating about that try to address that. And none of them are particularly satisfying, but they can at least perhaps give you some food for thought. And yeah, your generation will hopefully move that ball down the field a little bit further. So let's take a look at it. So over here, we have essentially the nicest picture that we've ever had of Venus, which was taken back in 1974 by the Mariner 10 spacecraft, which is from the United States in the NASA program. The Russians at the time were also working really heavily on getting to Venus. You know, it wasn't clear originally whether Venus would be inhospitable. There was some notion that it was hot. This was calculated because people came to understand that it had a very thick atmosphere that was carbon dioxide heavy, and people understood how the greenhouse effects would heat up the planet, and that turns out to be what's actually happening. We didn't know just how bad it would be until we got there, though. And so something like 70% of the sunlight that's incident on Venus is not reflected back. It's kept within Venus, which is really why it gets so gruesomely hot inside. Later on, this other map was generated, which is actually, this isn't just a photograph of Venus. This is actually an assemblage of different individual pieces that were imaged using radar, right? So radar is kind of an amazing tool. It's essentially using millimeter length waves of light, so really low energy but long wavelength light, to penetrate through gases and get a reflection back that can tell you something about how far away an object is. And so they were able to generate these maps, and they stitched it together and they filled in the blanks. And so these maps that you see of Venus are, I don't want to say they're misleading, but they're not entirely direct evidence. But we do have some idea of the surface features as a result of this, and that's going to play out here in just a minute. Like I said, Venus is very similar. It's about 82% the mass of Earth compared to Mars, which is like 11%. So it's more or less in our same ballpark. Really, the biggest difference that we can see in terms of just the objective features of it is that it doesn't have any liquid water. It has this really ridiculously thick atmosphere, which it turns out to be quite toxic, which is largely carbon dioxide and sulfuric acid. So I don't know if you guys have had the pleasure of taking chemistry lab yet, but sulfuric acid is about one of the nastiest substances that you could splash on your hands accidentally. It's not a fun place for spacecraft or for anything alive. So the idea, Venus played a central role in our reconception of the geocentric universe, and we talked about this briefly, but Venus has phases just like the moon, and these have to do with where its position is with respect to us and the sun. And this was something that was, how should I put this? This was something that was difficult to confirm because the optics weren't available. You couldn't throw a telescope up. They didn't have telescopes originally, obviously, and there was some reporting at different moments that there were phases of Venus, which would contradict the entire cosmology of almost every civilization up until the 1600s, when Galileo actually was able to throw a telescope up and confirm that, yeah, there are phases to Venus. But there were very interesting isolated reports. There's some mention as early as, there's little scattered hints throughout even the Babylonian texts that Venus had this crescent form to it. And there are actual reckonings of this as early as the first millennia AD in the Islamic astronomy texts that tried to make sense of this. And nobody was really going so far as to say that, hey, maybe the Earth isn't at the center of the universe. I think that would topple so much of the cosmology, and of course all these myths, and the framework upon which people had built their lives was centralized on the fact that where everything was happening was central, and everything that was playing out above it was sort of peripheral. And so, obviously the geocentric universe died a horrible death. It was not one that went lightly. And it's such an important story in the history of our understanding of our universe. And I think there's really similar ones playing out today that make it very, that have persisted into the future. And I hope you all will sign up and take the cosmology course next semester, where we'll spend several weeks dealing with how stars work. And then we're going to play with cosmology in general. So really what the universe means to us today. And we still have, in some sense, in my opinion, a very Earth-centric view in interpreting the data about cosmology, right? There's a number of pieces of data which are interpreted very much to mean that things are in relation to things, that all of the other bodies are moving in relation to the Earth. And I think that is, in some sense, a holdover of this cosmology, that the Earth is at the center of the universe, which is totally reasonable. And it's difficult to combat hundreds of thousands of years of storytelling and making sense of where we're at. So another thing that's kind of interesting is that there's a few reports of Venus transiting the sun, and those are debated as well. This is another piece of evidence that perhaps Venus was not orbiting the Earth, but was actually orbiting the sun. And there's a few mentions of this. Most scholars have chalked it up to sunspots, but they very well may have observed a transit of Venus, which means it passed between us and the sun. And the reason that you don't see very many transits of Venus is because it has this tilted orbit. And so these transit events happen very infrequently. Now they do seem to happen with some predictability. They seem to happen usually in early June or early December, which is that point where Venus crosses the ecliptic, or orbital plane. And they happen in 8-year intervals. So each pair of transits happens more than a century apart. So these are difficult things to keep track of if you don't have a huge bureaucracy that's keeping records for a very long time. It's more than a human lifetime. The most recent pair of Venus transits happened in 2004 and 2012, but before that, it was 1874 and 1882, and on back through time. So this is what it looks like if you have the right magnification. Little dot crisscrossing the sun. And it turns out the sun's actually one of the more easy things to image. You can cast it, you can project the sun from a lens onto a big screen, and you can see this happening. So that would be really cool if we can pull that off. Except the next one's not going to be until we're all dead, unfortunately. All right, so the Venus and Earth have this really beautiful 8 to 15 resonance with one another, which is very close to the 13th harmonic, which is the musical note that you don't find that often. I know some of you guys are way into music. The 13th harmonic is something of, it's called a neutral sixth. It's somewhere between a minor sixth and a major sixth. It's hardly ever used in Western music, but it would definitely create a strange sense of tension if you were to hear one. I kind of wish I brought an example of this. But this is what the this is what the orbit of Venus would look like from a geocentric view, which you can see is, it's actually quite beautiful, and it forms this wonderful little pentagram, which people were obsessed with, especially the mathematical Greeks, the Pythagoreans, were obsessed with this, and they took this as proof, again, that the Earth was at the center of the universe, because how could something so beautiful not be true? What's interesting, though, is that I think when you remap this, when you remap it and you actually draw a line between the Earth and Venus, putting, as we understand it now, the sun at the center of our solar system, you also get a magnificently beautiful pattern as a result of it, right? So I don't think it's wise to be too obsessed with any particular instance of beauty when it comes to interpreting scientific theories, because nature is unimaginably complex, and often the patterns that we're staring at can obscure other patterns which are equally as beautiful. And so you often hear this in fundamental physics today, that people are searching for these elegant and beautiful theories, and there's some problems with doing that, and we have to reorient ourselves towards really asking the question of how we resolve the contradictions. You know, that's one thing that I hope that you all come away from this class is understanding the broken parts of our understanding about the solar system, because you know it's only so interesting to understand the stories that we tell ourselves right now, but we have to understand where the stories are going to go in the future, because that's all the work that has to be done. And honestly, that's what's really exciting about science, is that we progress in our understanding. So there you have it. Venus still keeps a very beautiful pattern if you look at it, right? Which is obvious. This pattern's been adopted in numerous esoteric worlds. This is some sort of sacred geometry to different cultures. Okay, so Venus doesn't have any moons, which is, I think, really important, actually. We'll talk about that when we talk about core dynamics here in a minute. Venus does appear to have a few Trojans, at least one Trojan satellite, and probably others. So what's a Trojan satellite? Well, a Trojan satellite is something which is under the stable influence of both the orbiting body and another body. So in this case, the Sun and Venus, let's say right here with the red dot would be Venus. There's a number of stable points. These are called Lagranges. And so if you will encounter this word undoubtedly if you start studying space flight and space travel, which we've only had minimal time to address in this course, for better or for worse. But these are stable points. And the interesting thing about these stable points is that you can actually put an object there, or say one happens to find itself in these regions, they'll actually orbit these Lagrange points. And this is really useful because a lot of our satellites, we will stick in these Lagrange points because they can just hang out there all day. And so there's a number of different stations, telescopes that we'll put out there. Our geomagnetic sensors are all stationed at different Lagrange points. And so each satellite system, whether it's the Earth and the Moon or the Earth and the Sun, they're all going to have Lagrange points. And these are absolutely critical to stationary research and honestly, probably to space exploration in general. We're always going to be seeking out these Lagrange points, and each planet has a few of them naturally. We're going to do the giant planets next week. Jupiter has some enormous Lagrange points, and it has huge clusters of asteroids that just chase it at L5 and L4. So in front of it, there's always this big cluster of asteroids, and behind it, there's this big cluster, and you just sort of follow it around the sky, or around whatever you want to call it, the solar system, around the ecliptic. So this is something to really think about in terms of how we go about studying these places. But as far as we know it, Venus doesn't really have any serious satellites other than potentially a few Trojan asteroids. Here's another way of looking at Lagrange points I think might make sense to you. I generally try to avoid these gravity well ideas because they're, I think, overly complex and abstract, but this gives you a sense of how it works because each one of these bodies creates, if you think about these holes as how much gravitational influence each one of these bodies has, and the spheres of influence radiating out, you have actually a resonance, a combination of these two different gravities at these different points. And so you can think of it as these nice little pseudo-gravitational wells that are appearing on either side of it. I just think it's a really cool concept, and you should probably be aware of it because it's playing a huge role in all of our space missions going on right now. And you'll often, if you read, pop science pieces, you'll hear about this satellite is stationed at L2 or stationed at wherever. Often they'll use L1 and L2 because they can get away from the moon that way. They can see the sun better, or they could maybe block out the light from the sun if they go over on L2. So, all right, enough about that. So this is kind of cool. I mentioned that Venus is one of the brighter objects in the sky. It turns out it's actually the third brightest after the sun and the moon, and I think that's of no small importance to the central role that Venus has played in all of these cultures across time. You can actually see it over here. There's that bright object is the moon, and Venus is next to it, and perhaps you will begin to notice Venus yourself after this lecture as you go out and check out the night sky. If you don't have one of those little apps on your phone that allows you to check out the stars, go get one. They're free. They're absolutely magnificent, and they will help you orient yourself. And after a while, you will just begin to notice what the different stars and planets are without even having to look at it. Once you pick these things out, they tend to sort of stick in your mind, which is cool. So people have been observing this for thousands of years. Here's a picture of Venus right next to the moon. Now, like I said, there's been a considerable debate about whether people realize that Venus had phases. There's people who report now that they can see the crescent shape of Venus with the naked eye. And there's been some double blinding of that, and it seems like it's possible. So this is just taken with like an iPhone camera or something like that. I find it hard to believe that people weren't able to see the crescent shape of it. Now, whether they intentionally didn't want to see it because it conflicted with their cosmology, which is completely understandable, or whether people literally just didn't see it, I don't know. But it seems like it can be seen with the naked eye. I urge you all to try. Let me know if any of you are able to see the crescent shape of Venus. Certainly people report that it did. A lot of our early astronomy records go back to the Sumerians and the Mesopotamians. I shouldn't say the Sumerians, but there was a number of Mesopotamian civilizations: Babylonians, the Sumerians, the Akkadians. They're also culturally distinct, but also culturally related. And so our story kind of starts in Mesopotamia because it's where we have the best records that in some sense relate in the way that we continue to do astronomy in the West. I think you can think about these different cultures as something like the difference between, say, England, Australia, the United States, and Canada, right? They all speak the same language. Our laws are pretty much the same. You could probably move from one country to the other and very little would change about your life. And I think these different cultures in Mesopotamia were rather similar. They shared religious archetypes for the most part. They changed the names a little bit to suit their particular everyday lives or their situations. but they're more or less the same. And actually, the way in which they shift is quite interesting. So we'll talk about that too. One thing that's really interesting is almost all of these cultures thought of Venus as two different stars, which you might think is kind of odd. But Venus does this strange thing. It appears in the evening when it's on one side of the sun, and then it appears in the morning on the other side of the sun. And in between, you can't see it at all. And I think this played heavily into the stories that people ended up mapping onto the stars as they looked up. Because what we see over and over again is this story of some god, some archetypical personality that's descending down below the horizon, down below, the disk that we live on, down below the dome, and then rising back up again. And this is one of the most central features of almost all mythologies. There's almost always some story in the hero's quest in which they descend into the underworld and conquer some monster and rise up again. It's really interesting how that's played out in different cultures, because it reflects oftentimes the different revolutionary stories that they're undergoing, their fights against tyranny and oppression, and they play it all out according to this paradigm, which is simply the matter of the Venus planet passing in front of the sun where it can't be seen. And almost no one treated it as the same planet. These were when it reemerged, it was a different being altogether. It was transformed in some way. And, that's not without exception. What's really interesting is that there was, like I mentioned, I think in a different lecture, that the Sumerians had a distinct class of people who were the astronomers. They lived in their own part of town and everything. They were actually not actually a revered class. They were more of a servant class, which is quite fascinating. That class of people seemed to understand that Venus was two different stars, and they made notes of that, but it didn't work its way into the general attitudes or culture of the people. And this is really, really important, because we have this ability as human beings, and you can call it cognitive dissonance or bias or whatever you want, but we have this real amazing ability not to look at things we don't want to see. I think that's just absolutely fascinating about human beings. We find models that work, find patterns that work, and so long as they work, so long as, say, our mythology works, or so long as our idea of how gravitation works, and we can build useful devices, we can build spacecraft, or we can model our civilization such that it's not complete chaos, we want to stick to it no matter what. Even if there's contradictory pieces of information that crop up, we're like, I don't want to deal with that, because what we've got going here is so good. And I don't think that means that we're idiots. I think that means that we're deeply committed to a harmonious existence. But it can get in the way of us understanding objectively what's happening in the universe. And it's something that in some sense we have to be, we have to be aware of and fight back against as scientists. And I'll treat you all as if you're newborn scientists, because I'm sure some of you will grow into scientists, and this is something that can't be overstated enough. So, myths, right? Venus is at the center of so many different myths. This word mythos, myth, the Greeks called it mythos. It's often in today's understanding treated as a myth is something that's not objectively true. I don't think that's quite the right way to look at it. And so oftentimes when we identify some story as a myth, we're like, well, that's not really how it went. It's some sort of like superstitious idea. But I think that's actually couldn't be further than the truth, because if you're a Sumerian walking around in the 3rd millennium BC, and you have to make sense of how you should be living, it's not going to do you much good to treat Venus as a ball of rock that's rolling around in the sky. It's much more useful for you to frame your narrative on Earth based on that. So I think the myths are really, really important. In some sense, it's a bit of a tragedy that we don't preserve them as well as we used to. Of course, we still have Hollywood, and there's some vestiges of literature remaining, but this could be, the loss of myth could be a huge player in some of the cultural malaise that's appearing in the world today. You know, young people are killing themselves in the United States at an unprecedented rate. I mean, not to get into like depressing territory, but there's a real crisis of meaning in our society right now. I mean, you can do anything you want. You can make up your own religion. You can make up anything you want about yourself, but it's not clear that that's making people more happy. And so the myths of these cultures bound people together under this worldview of what was good, what was bad. And you might say, well, it's obvious what's good and what's bad, but it's not always so obvious because things come into conflict, right? People have different needs and they butt up against one another. And solving those problems is a lot easier if you have a general cosmology that allows you to point at something, say, a goddess like Ishtar, which is what the Sumerians called Venus, Ishtar was the Akkadian Babylonian version of Inanna, which was the Sumerian goddess, who really embodied different roles, right? Inanna and the goddess that was associated embodied love and also embodied war on the other side. There's this dualism that emerges in every single one of these cultures. There's the morning star, the evening star. And there's sort of these two ideals of what it looks like. And, you know, obviously love and war, you know, are completely bound up with one another. I'm sure all of you have made your way into your first romantic relationships. And I'm sure that all of those relationships very much embodied love and war at some points. You know, this completely enveloping and harmonious force of beauty and union and intimacy that's completely counterbalanced maybe 5 minutes later by complete chaos and destruction. And the ancients realized this, and they told these stories, particularly the Sumerians. The Mesopotamians understood this, and they told this story of Inanna, who was also presiding over both birth and death. So all of these dualities as they appear were very easily played out in the story of Venus. You know, both birth and death, if taken as separate entities, are very difficult to reconcile. They don't really give you much comfort in either way. But if you start to treat them as two sides of the same coin, which I think is totally reasonable way to look at life, because, you know, what is generation of a new life form from yourself, from your own body, if not some sort of conquering of death in and of itself, right? I mean, you know, your body is going to not make it into the next century, but you can spawn an offspring which will, in some sense, immortalize you. And so they really do seem to be two sides of the same coin, life and death, and birth and death. And the Mesopotamians got this. Almost every culture got this. You know, one thing that's really interesting, they tell this story. This story appears over and over again with this time frame that that this goddess, Inanna, descends into the underworld, and she's actually killed down there. She spends 3 days in the underworld, and then she is resurrected and rises in this new form 3 days later. And this is interesting because, you know, Venus is actually has this cycle, right, where its orbit lines up with ours in this really interesting way, in such that the evening star appears on one side for about 263 days, whereas the morning star also appears on the other side, but it's missing for about 8 days, right? And I'm not sure how they came up with 3 out of this, which is interesting. It's actually missing for 8 days, but this 3-day mythology appears obviously as thousands of years later in the Christian mythology as the death and resurrection of Jesus, which is really interesting. So, you know, this is such an important story that it's persisted across numerous cultures into the Latin Roman universe. where we have the story of Jesus. It's that important to people that it's been held on to. Now, why did they say 3 days when it's actually missing for 8 days? I don't know. I was racking my brain about this a bit. The Babylonians obviously had this system that was based on their counting was based on sixes. Obviously, half of 6 is 3. I could imagine, that the word 3 also, in addition to meaning literally 3, it could have also meant something like a few, right? Sometimes we'll do that in English too. We'll say, maybe a couple of days means 2 days or something roughly. But sometimes people could say a couple of days and they mean like 4 days, right? Something like that, where it's disappearing for a little bit of time. And so these numbers often in mythology don't necessarily mean objectively the numbers that we're looking at. In general, the mythology is not this literal astronomical sense that we think of in terms of objective science like we do today. It's more or less trying to get at some general idea and frame it in a way that you can conceive of. And so that's just a really fascinating origin story for pretty much all that comes next. Another culture, oh, by the way, this is, you can see, this is where the Sumerian and Babylonian cultures were located. This is, in some sense, the birth of the West here, which is kind of a real tragedy because I don't know if any of you noticed, but this is Iraq, right? These cities have all been completely toasted and burned to the ground by now, mainly in modern times, right? We've not necessarily coalition forces, but between all of the different extremist groups and the coalition bombings, all of these ancient cities have been essentially razed to the ground, which is a real tragedy. And it's sort of tragic that we've lost the framing of the origins of all of our stories, right? I mean, I'm telling you, this resurrection story from the Bible, which was central to our country for hundreds of years, obviously religion is not winning any medals right now. It's not extremely popular, but those stories trace back to the civilization, which has basically been destroyed, not just by time, but by our own actions. And it's interesting that it didn't really get the framing that it deserved when all those conflicts were unfolding. They're still unfolding today, I suppose. But this is in some sense our origin place for our culture that we have in the West today. And I don't know, it's a very tragic moment in terms of the way that we would treat our birthplace of our culture. The way that we've treated it is quite tragic, I think. Something to think about. Okay, so there was another culture that was developing alongside the Mesopotamian culture. And this one doesn't get enough airplay, but it's one of my favorite cultures in antiquity. I think that it's worth thinking about. This is the Canaanite culture. And you might recognize the word Canaanite. It's also found in the Bible many, many times. Because the Canaanite people were essentially those that occupied the Levant and the interior Mediterranean. And they were the ethnic, cultural population from which the Hebrews emerged, and the whole story of the Hebrew Bible came out of that. So it's sort of like, you can think about it as if like the Hebrews were a particular religious sect within a wider culture. It would be sort of like if there was a cult in Southern Oregon, but they were still part of the United States, right? So the Canaanite culture was the wider United States in that metaphor. And the Canaanites were known, this was what they called themselves. The Greeks called them the Phoenicians, which is really interesting. And the Phoenicians these people were revered for their ability to create ships. They had trading posts up all around the Mediterranean long before anyone else did. And I think the reason they don't get a lot of airplay in history books is because they didn't build huge cities necessarily. They weren't conquering territory much like, say, the Romans or the Greeks, or even the Mesopotamians. They were a merchant class of people, and they were the ones who came up with essentially the basic floor plan for the ship as we know it, the ship that the Romans used, the Greeks used. These guys were great traders, and like I said, the Greeks called them the Phoenicians. That's essentially, that word can boil down to the color purple. So they called them the purple people, because the Phoenicians were able to extract this dye from the shells of a particular mollusk, and they made this dye that was very valuable, and it made its way into the tunics of the Greeks and so on and so forth. They were very rich people. They had a lot of money. They just didn't have a lot of land. So they get kind of an afterthought. And this was this all was going on around, like I said, the same time, 3000 BC, maybe as far as our records go back with this. You know, I think it's worth making a small aside here that we talk about the Bronze Age, we talk about the Iron Age, we talk about Stone Age, maybe before that, or Copper Age. And we treat these dates as if these were the first time that humans had ever come up with the idea of bronze or stone or iron. And there's reason to believe that they were innovated at the times that they were said to have been innovated. But we don't know if that was the first time that it happened. What's really fascinating about the material bronze and the material iron and so forth is that they have decay or corrosion rates that are essentially commensurate with where we see them in the record. So another way of putting that is to say, if you had a piece of bronze back then, in the Bronze Age, most of it will have disintegrated by now. This is the last vestige of 3,000, let's see, 5,000 years ago is about how long you would expect bronze to survive. Iron survives even less, right? It rusts very easily. And the Iron Age came later, but iron would probably only survive for a couple thousand years, iron artifacts, right? So if there was an Iron Age 50,000 years ago, you would have nothing left of it. There's not going to be any pieces of iron from that. I think this is a really important blind spot to keep track of when we tell these stories. So anyways, this was all occurring in the Bronze Age. And in the ancient Canaanite religion, the morning star was given this personification called Atar. Now, one of the really interesting bait and switches that happens here, and we see this with the Romans and Greeks too, is that Atar is essentially Inanna from the Mesopotamian tradition, but it's a man. So there's a cultural shift in this society where the story is rewritten not with the feminine being the central story player, but the masculine. And this is something that that we see in a transition between the Minoans and the Greeks as well. There's a transition from the feminine to the masculine. But I think that's really important to keep in mind because, you know, it's often assumed, especially in sort of mid-wit discussions about the political landscape today and so forth, that you know, that society is laid out this way, and you know, that men have always been in charge of things and so forth, and it's not really so. That's what's interesting. Different cultures have operated differently. I don't see there any reason to believe that there's anything particularly biologically necessary about men ruling things necessarily, and it doesn't seem to have been the case so far. And I'm not trying to put men down at all. I'm obviously a man, and I think that I'm capable of making decisions, but it's important to remember it hasn't always been that way. So the interesting thing about Atar was that Atar tells the story of this descent, which is actually aimed at overthrowing a tyrannical underling god in the underworld, right? And in some senses, this can be thought of as mirroring the escape of the Canaanite people from the tyranny of the Mesopotamian civilizations, the Sumerians and the Babylonians, who actually held them captive for quite a while. And this is told out in the story in some different biblical stories. So Atar was descending and trying to take over the throne of Baal, who occupied the underworld. And Baal is interesting because Baal can be shortened, is often given the title of El, and often the generic term El is used in the Canaanite religion. And this is a really interesting word because if you speak Spanish or something, you'll realize that el is actually the word for the, right? But if you think about the word the, where does that word come from? Well, the word the has the word the in it, which is the shortened form of the word theos, which is a Greek term for God. And so there's something really interesting where we're actually, when we give these articles to objects, we're actually sort of deifying them in a sense, right? I'm like, this is the hat, or this is the professor, right? You're actually giving some sort of significance to that object that is in some sense putting it in an archetypical position. It's almost, I don't want to say godlike, but certainly implies some sort of ownership or lordship over things. And this is really fascinating. And that word El throughout the Hebrew Bible and throughout the Canaanite religion seems to really indicate someone who is a lord or an owner, right? And so overthrowing someone who's a lord or an owner has interesting revolutionary overtones to it, because these stories are actually playing out how they saw the overturning of civilization and how they ended, how they actually made their revolution and broke themselves off from the captivity of the Babylonians. So that's pretty cool. What else? Later on, you know, the Hebrews in their own Bible, which was essentially way downstream of the Canaanites. So like I said, the Hebrews were split off from the Canaanites. And they told a story of Venus that was a little bit different. And you can find that story actually in the King James Bible today. And what's interesting is that the word used for Venus in this Hebrew Bible means like shining one or illuminated one. And we actually, this actually, a Latinization of that is Lucifer, which is quite interesting. And so this descent and the story that we see coming out of the New Testament even is the story of this fallen angel, right? It's the story of descent, once again, which plays right back into the actual transit of this planet as it disappears from our horizon every time. And the stories that we hang on that map directly to the astronomy, which is fascinating. Just going to read you a little piece of that. You know, this is, I think that it's worth doing because you can just see exactly how this plays onto the actual motion of this body in the sky. This is a piece from the Hebrew Bible. This is Isaiah 14:12. It says, "How you have fallen from heaven, morning star," which is Lucifer, "son of dawn. You have been cast down to the earth, you who once laid low the nations. You said in your heart, I will ascend to the heavens. I will raise my throne above the stars of God. I will sit enthroned on the mount of assembly, on the utmost heights of Mount Zaphon. I will ascend above the cloud tops. I will make myself the most high. But you are brought down to the realm of the dead, to the depths of the pit. Those who see you stare at you. They ponder your fate. Is this the man who shook the earth and made kingdoms tremble? The man who made the world a wilderness, who overthrew its cities and would not let his captives go home?" So, you know, there's this whole story, there's this story, and we'll see it appear in a couple of other cultures where you fly too close to the sun and you melt your wings kind of thing, right? You try to elevate yourself above the highest ideal and you're bound to fail. And that's sort of the story of the fall of Lucifer, which is captured in the not only in the Hebrew Bible, but more in the New Testament, and really develops in the Milton poem Paradise Lost, which I highly recommend. It is just this devastating story of what happens when you try to be something that you're not. And that's a terrible thing to do, right? I mean, we've all experienced that in life too, where you try to make your, like, if I was to say, can somebody tell me, do you all understand the history of the origin of life on Earth? And maybe people would kind of nod their head or something, right? But you don't, probably. And there's so many times in life where we find ourselves in these pickles where we claim to be something that we're not. We claim to have some understanding that we don't. And it lends us into all sorts of chaos and problems. And so this was playing out in these mythologies. The Egyptians had two separate gods, which they used to describe which they used to map onto Venus. And again, we see this descent into the underworld. They actually pin this onto the god Osiris, who descends into the underworld and gets torn up and then is put back together and sent back up as a new deity by a different god. Very similar. In India, we see a very similar resurrection story that involves this god who you can see here, which is called Shukra, who is actually one of the I'm going to mess it up, but when we were looking at the story of the bear in the sky, the Hindus assigned different sages to each one of the stars in the Dipper, and Shukra is one of them. But again, Shukra is sort of given this knowledge in the underworld of how to bring the dead back to life. So there's this story of death and rebirth. And there's really no reason to believe that the Hindus were in contact with some people argue about that. But it's not necessarily obvious that the Hindus were in contact with the West when they were deriving their own mythologies. But for some reason, they come up with the exact same thing. And when we get to the Mayans, there's almost no argument to be made that they understood what was going on in the West, and yet they still have this same resurrection story that appears, right? And that must mean that there's something deeply true about that story, and that it is true that birth and death are linked in this way, and that there's a way to conceptualize them in a way that integrates the understanding such that you can live a better life. I think that's what it really comes down to. The Indians had some great astronomy going as early as 1000 BC. They had figured out the orbital period of Venus and so forth. I think I mentioned the Islamic traditions a little bit earlier too. They had also done a great job of keeping track of this, and I think that there's some whisperings that they had figured out the phases of Venus as early as 1000 AD, which is quite fascinating. Again, though, in the Islamic tradition, you have this descent and ascent to heaven. I'm kind of running out of time, so I won't go into that one too deep. I do want to mention the Mayans, though, and really the whole Mesoamerican tradition. The Mayan, the reason that we have less to say about some of these other cultures than we do about the Sumerians and so forth is because the records haven't been preserved very well. A lot of the records that we have about the Mesoamericans really come down to oral traditions, and the oral traditions divide very quickly. It's sort of like a game of telephone where things change over and over again, but you'll see the same pattern showing up. So oftentimes Venus is associated with Quetzalcoatl, who is the god of the morning star, and his twin, I don't know how to say this, Xotli was the evening star. And there's this story about how Quetzalcoatl, this winged serpent, flew too close to the sun, tried to speak to it, but his pride and hubris overcome him. He burnt his tongue and was no more capable of speaking and giving wisdom. And this is so similar to the fallen angel story that we see in the Western traditions as well. And you really have to ask yourself how that's possible. Let's keep rolling. Different indigenous traditions also, you see this in the Aboriginal cultures, you see a very similar story. Again, in southern Chile, the Mapuche Indians, the native indigenous people, have a very similar story where the spirits attempt to ascend back from the world below. They get stuck there. They have this giant transformative experience and then ascend as a new version of themselves, right? There's this transformative process, right? I think that's really, in the West, that's really captured in the Christian tradition of this idea of transforming yourself. There's this idea of forgiveness, that once you recognize that you're being a bad person, that's kind of good enough. You can become a new person once you realize that. And so, that's been played out in different ways, and the different priesthoods have inserted themselves into it in different ways. for better or for worse. Okay, so spent a lot of time on mythology. I wish I could have spent more time on it. I want to talk about Venus. Venus as a planet, and we'll probably have to finish it next time, but that's fine because we'll talk about Mars as well, and then we can compare and contrast them. So, you know, we've sent something like 50 different spacecraft to Venus. Only about half of them worked out, right? Terribly vicious planet. The first successful one was this Mariner 2 flyby. The Soviets, however, really cleaned up and did most of the heavy lifting at Venus in the 1970s. They landed the first probe, which was Venera 7, which Venera in Russian means Venus, you know, which really says something actually too, because the Russians adopting the Greek tradition is kind of strange if you think about it. I think the Russians have very little in common with the Greeks culturally, and yet they also choose to use this language to describe their probe, which really makes you think. Venera 7 only operated for 23 minutes before it got cooked, and then they kept sending probes and so on and so forth. So this is an ongoing project, and there's several missions that are planned. And this is a false color version of that same image that I showed you at the beginning of the lecture, which is a radar map, which was generated by the US Pioneer orbiter in the 70s. The Soviets really cleaned it up and did better jobs of it with Venera 15 and 16. But eventually, the US in the 80s put forth a spacecraft called Magellan that did an even better job. And this is where we've gotten most of our recent data from, is from this Magellan probe. Which actually, the Magellan spacecraft actually has generated more data than all of the other missions combined at this point. Some extraordinary amounts of data, something like 30 encyclopedias worth of data. Just another view of it. Something like 75% of the surface of Venus is this volcanic lowland stuff. These are, the lava plains are very similar to the lunar Maria that we talked about. And then there's this highland portion, which are these raised, the brighter portions you see. These we actually treat them as continents, which is quite interesting. The largest one of those continents stretches along the equator. It's called Aphrodite, which is fascinating because that's the Greek version of Venus. And you know, these myths persist into our cultural mindset as we reach out into the solar system. They're not insignificant. We're carrying them around for a reason. We do value them, even if we can't put our tongue on the reason why we value them. That's why I think they're so important to spend time thinking about. Here's some rather grainy pictures that we've gotten back from Venus. You know, we tried to calculate the age of the surface of Venus, and we can do that using the cratering method. But when we calculate the age of Venus using the cratering method, we come back with an age of something like 300 million years, which everybody pretty much agrees makes no sense at all. I don't think anyone thinks that a planet formed so quickly or so recently, right? And so the idea is that the surface has been remodeled very recently. And the way that it was remodeled isn't totally clear. That's also worth mentioning. You know, I think one of the more popular narratives is that there was some spurt of supervolcanoes that plastered it with magma, fresh magma. That, if it was true, would have no precedence in our observational history. We've never seen anything like that happen. It's very difficult to imagine. Perhaps it was smashed into by another planet, but if it was smashed into by another planet, where is that planet? Where is the debris from it? How come the orbit is so stable at this point, if it was the case? You know, something really weird about Venus is that it rotates the wrong way. That's something to really think about. So everybody else, I guess Uranus also rotates the wrong way, and we'll get to that. It rotates in a very strange way. But Venus barely rotates, and it rotates opposite the direction of its orbit. was very strange. So there's something really fascinating about the history of Venus, which I hope that we can start to uncover. With 5 minutes left in this talk today, we'll probably not get to the bottom of it, but I want you to go away and think about it a bit. So, you know, there's all of these evident volcanic mountains. You can see a few of them here. And it's thought that these are places where convection is transporting interior heat to the surface. And you can see other evidence of it. There's this tectonic stretching of the crust. And that's what these little ripples are. And so there's evidence of convection. There's evidence of tectonics. But for some reason, like we said, there's something distinctly different about Venus because it has no magnetic field. And I think I'll close talking about this magnetic field problem because it got me really thinking about what could be causing this. Because when I went and was reading about it, you know, you'll often, the go-to answer that you'll usually hear from people as to why Venus doesn't have a magnetic field is because it doesn't have sufficient convection to drive the dynamo that's necessary. But that's, you know, that's very quickly contradicted by other pieces of literature that are talking about the surface geology of Venus, where there is plenty of convection. So, and Venus is very geologically active. There's tons of active volcanoes on it. So what's going on? Why does Earth have this very generous magnetic field and Venus has none? There's a few possibilities for that. You know, one is that it doesn't have a solid inner core. It's just all liquid. And again, the problem with having no solid core, and honestly, without having a solid core in any electromagnet, is you can't sustain a magnetic field. It won't be stable. It will just be sort of chaotic and it'll dissipate very quickly. So that's one possibility. But I came across this other idea that was quite interesting, which is that if you use the convection model to explain why we have a magnetic field, you run into a serious problem. The serious problem is that convection requires you to be losing heat, a lot of heat, right? So since the Earth's, since the most distant date we have on the Earth, which will be often referred to as the formation of the Earth, although I think that's a bit misleading, but the oldest date we have on the Earth, let's say 4.5 billion years ago, it should have lost something like 3,000 degrees Celsius over that amount of time. And this is obviously impossible because it would be cooled just as much as that solid mantle picture I showed you of Venus. So it doesn't make any sense. There's a bunch of missing heat using this model. Now, what's really cool is that a number of different groups have been working on this problem in the last few years. And what they did was they started looking at the moon. Because just like we were talking about keeping Mercury, just like you mentioned, keeping Mercury, keeping its magnetism active involved this sloshing effect, right? People have started looking at the moon because what's really interesting about our moon system is our moon relative to the size of our planet is unprecedented in the solar system. It's huge. The moon is enormous compared to most planets' size to satellite ratio. So we have this huge moon that's orbiting us that makes enormous tides, which we see in the ocean. And some scientists recently calculated that that amount of heat, the amount of energy that's necessary to drive those cells, right? Those solenoid cells, those electrically active liquid core cells, can be made up for by the pull of the moon itself. And so I think this will be a really cool paradigm shift that will start popping up in the textbooks, within the next few years. I think that we're going to start thinking about how the moon is actually extremely central to what makes the Earth the place that we love so much today. Let's stop there, and we'll pick up with the rest of this and with Mars on Thursday.